Okay, welcome to our unit on 2D motion. It's 2D motion. In your book and other places you might see it called projectile motion. So we're going to be looking at objects that are either thrown horizontally off a cliff or thrown at some angle, and we can figure out how far is it going to fall, how much time will it take, how far will it go in the X direction, and we can also figure out how fast it was thrown in the X direction. So to start this off, let's go ahead and look at a scenario. Let's say that we are in the Air Force and we are dropping off supplies to one of our allies. And we have a specific spot that we want to drop these materials. Right. And so we've got this spot here. Let's mark it with X. So that's where we want to drop the materials. So let's say we've got this box on the bottom of our plane, and we're going to let it go, and we want it to land on that X. So the question becomes, where should I let it go? So when we're thinking about this, what are some variables that we're going to take into account? Well, we should think that the plane is moving in this direction with some speed. The box is attached to the plane, so that means the box has the same speed as the plane. Okay, so all three of these planes assume it's the same plane moving the same speed. So that means it has some, what we call initial speed in the X direction. Right? Now, something else that we might think about is, okay, when we let this go, what's going to happen? Well, gravity is going to pull it down. So with this, we call it AY. Right? AY is equal to negative G, which we'll talk about in more detail in just a second. Right? We also might think, well, there's going to be wind, so the wind might push the box in one direction or the other. And then we might also think, okay, well, how high off the ground am I? Right? Because that can also determine when I need to let go of the box. So we call that displacement in the Y direction. Right? Then we also need to think about, okay, what path will this box take once I let it go? And so let me give you some options, and then as you're watching, you can pick, and then I'll tell you which one is correct. So let's say maybe when I let it go, the box will go do something like this. Or maybe the box just does this when I let it go. Just goes straight down. Or it could also possibly do something like this. I'm going to make a parabola. Or kind of option 4, will it do something like this? Alright, so we've got 4 options. Let's say it's a multiple choice question, A, B, C, and D. Which one would be the correct path? It ends up being option D. So knowing that's the path that it would take, where should we let the box go? Well, it ends up being from the plane from the left. So if we let it go, we would expect it to take a path like this. All right, that was a terrible example. But I'm going to take something like that. All right, so explanation why. The box has the same speed as the plane since it's attached. Then we have this phenomenon called inertia, which is just something that says that an object will continue doing what it's already doing unless acted upon by an unbalanced force. Right? So in this case, and in all of our 2D motion, we are going to ignore air resistance. So that means there is no unbalanced force. There's no force that's going to end up pushing the box in the opposite direction. So that initial speed will push it, and it will continue in the X direction until it hits the target. And then, of course, gravity is what brings it down. So this parabola shape is what we see is a combination of the X direction and then the Y direction pulling it down. So with 2D motion, what we end up doing is we split the X and the Y up into two different sections, and then that's how we'll also solve the problems. So specifically, in the X direction, we've already said this once, but in the X direction, we are neglecting air resistance. So, like I said, if we're neglecting air resistance, there's no force that's going to push it back the other way. So if it's moving from left to right, it's going to continue moving left to right at the same speed. So that means that AX, or acceleration in the X direction, so A and then subscript X equals 0. So in other words, acceleration in the X direction is always 0. So horizontally, acceleration is 0. So if we're not accelerating, in other words, we're not speeding up or slowing down, then that means that UX, or initial velocity in the X direction, is equal to, and will always be equal to, final velocity in the X direction. Right, so this is always true. Very important. All right. Now, in the real world, is this true? No. But for our problems, UX will always be equal to VX. Now, for the Y direction, so vertically, up and down, we know that gravity causes objects to fall. And we've noticed on Earth that gravity is constant. Right, so acceleration in the Y direction is equal to negative G. And since AY, or acceleration in the Y direction, is equal to negative G, then UY, or initial velocity in the Y direction, can never equal final velocity in the Y direction. And final velocity is almost always going to be greater than initial velocity, right, in these problems. So, how do we solve 2D motion problems? Well, we end up using the same SUVAT equations. The same equations that we've been using in 1D motion. But we just make a few slight changes. So, I'm going to split these up side by side, have our X on the left and Y on the right. So there's three main equations that we used in SUVAT, and there's three that are most helpful. So in the X direction, I'll write down that displacement in the X direction is equal to initial velocity in the X times time plus 1/2 AX t squared. Same equation as we had in 1D motion. We've just added the subscripts to let you know that we're in the x direction. We're dealing in the horizontal. The other two equations that are helpful would be Vx equals Ux plus AXT, and then V squared equals U squared plus 2AS. Right. And then we have the exact same equations in the y, except we're just going to denote that we are in the y direction. So displacement in the y direction is equal to uy times t plus 1/2 ay t squared. And we'll do the same thing for the next two equations. So Vy equals uy plus ayt, and then so now what we'll do is we'll just look at those two rules that we just looked at up above. So we'll look at AX is equal to 0 in the x direction, and then we'll also look at AY is equal to negative G. And then what we'll do is just plug those into our equations and see how they affect them. So, for example, let's start in the x direction. So we said that AX is equal to 0. So how does that affect these three equations? Well, in the first equation, if AX is equal to 0, that's going to cancel out this entire quantity right here. And all we're left with is SX equals UX times T. In the second equation, it's going to cancel out this whole quantity, and all we're left with is Vx equals Ux, which by rule, that makes sense because we said that if there's no acceleration, then final speed will be equal to initial speed. And that's exactly what this equation says. And then the last equation in the x direction, 2AS, we plug in 0 for AX. That cancels this whole quantity out, and we're left with Vx squared equals Ux squared, which says the same thing as these two. And so really these two equations right here become obsolete. So all we're left with in the x direction is Sx equals Ux times T. So let's go ahead and go to the y direction and do the same thing. Except we talked about, instead of ay being 0, ay is equal to negative g, or gravity, or negative 9.8. Alright, so how does that affect this equation? If we, instead of having ay, we now have negative g. Right, well, let's go ahead and rewrite that equation. We would have sy equals uy times t. Instead of plus 1/2, we could just say minus 1/2 gt squared. Right, and let's do that same thing for the second and third equation. So the second equation is Vy equals uy, and instead of plus ayt, we could just say minus gt. And finally, we would have Vy squared equals uy squared, and instead of having plus 2 AYSY, we could just say minus 2GSY. So, now knowing we have 4 equations. Really, they're not new. We have just now substituted some values that are known. So how would we go about solving a problem given to us in 2D? The first few problems that we're going to have are being launched horizontally. So for example, I think one of your first practice problems you'll have from the book is there's a ball on a table, it's got some initial velocity, and then it travels off the table. So it was launched horizontally off the table. So how do we go about solving a problem like that? Well, step 1 is we use the y direction equations. To solve for time. And then, once you have solved the y direction equations for time, you will then plug in that time into your x direction equation, and solve for the missing variable. Now, one major thing that we need to go over, in between step 1 and 2, do not round. So do not round your time that you find in your y direction and then when you plug it into your x direction. So do not round in between step 1 and 2. All right, so when you're going from step 1 to step 2, do not round. All right, so let's look at a problem. So, let's say an airplane is going to drop off a box, and we know that we have to be flying at an altitude of 321 meters. Right, so we know one of our displacements is 321 meters, and with the trees and other things that are surrounding this village that we're dropping stuff on, we have 45 meters across to fit this box into. So we've got another displacement that equals 45 meters. We know that gravity, since we're on Earth, so G is equal to 9.8. Now, the reason I know I'm calling it positive right now is because if you remember in our equation, we plugged in negative G. So I've already plugged in the negative. So here, kind of a side note, is plug in a positive 9.8 for G, because we've already taken care of the negative. So we also know that the initial velocity in the y direction, right, we're going to be flying horizontally, staying at the same altitude, so we know that uy is equal to 0. We want to know how fast must we be flying in the x direction in order to land this box in the safe zone. So before we go and actually solve this problem, let's figure out our two displacements. So I said that we're going to be flying at an altitude of 321 meters. So is that SY or SX? Well, it's altitude, so it's the y direction, so that would be SY. And we also know that the box is dropping 321 meters, so that is actually negative. So negative 321 meters displacement in the y. So therefore, we said we had about 45 meters to drop this box in. That's in the x direction, so SX. So now let's go ahead and follow the steps. Step 1 is to solve for time in the y direction. Alright, so what do we know about this situation in the y direction? Well, we know that displacement in the y is negative 321. We know that uy is equal to 0. So let's look at the equations and pick which one we need. I'm looking at this one. This one has uy, sy, g, and has t. So that one looks good. And the last two, they both have final velocity. And I do not know the final velocity in the y direction, so I cannot use those two equations. So I'm going to use the first one. So start off with my equation. Sy equals uy times t plus 1/2 minus 1/2 gt squared. Now I know that uy is equal to 0, so this whole quantity right here is going to disappear. So all we're going to be left with is sy equals negative 1/2 gt squared. Alright, so let's go ahead and plug this in. So we got negative 321 equals negative 1/2 gt squared. And g is actually equal to 9.8. So go ahead and plug that in. So now let's go ahead and follow the order of operations and solve this problem. So negative 1/2 times 9.8 is just negative 4.9 t squared. Still have negative 321 on the left side. Divide by negative 4.9. Get 65.5 equals t squared. Okay. Square root. Right. And in my calculator, I get this really long number. Now, I'm going to, just for your purpose, I'm going to write down the first 3 digits, but just to let you know that this is a very long number, and I'm going to keep that number in my calculator for the next problem. Right, but I am not going to round between step 1 and step 2. So we have just finished step 1. We solve for time in the y direction. Now part 2. Right. We're ultimately trying to find with what speed do I need to fly with. So initial speed in the x. So now I'm going to use the x direction equation that we're left with. Sx equals ux times t. Well, I know the space that I have. That was 45 meters. And I don't know ux. And I found this quantity in time in the y direction, which was, I'll just put 8.09 on here, but just remember that I did not round in my calculator. Then all that's left is to divide both sides by the time, and I get an initial speed, initial velocity of 5.56 meters per second. Right. Now, there's an assignment on Schoology. You can go check it out. But just follow these steps, solve for time in the y direction, and then you'll plug that time in for the s direction, and you'll be able to solve these problems.